The next topic consists of two rules, the empirical rule and the Chebyshev rule. Now these two rules are about finding an interval and then determining how many data observations will fall within that interval. And we can use this to find what is a reasonable interval within which data would appear. And if a data occurs outside this interval, then we know that that's an unusual observation. So empirical rule works for data that has a nice symmetric bell-shaped distribution. If that is so, if the data has a bell-shaped distribution, then if you start from the center, mean mu, and you determine a one standard deviation interval, meaning mu minus 1 sigma plus 1 sigma. So if you take that 1 sigma interval, one standard deviation from the mean, then that interval will contain 68% of all the data within that one standard deviation interval. And the empirical rule also says that if you construct a two standard deviation interval, okay, like that, then 95% of the data will fall within that interval. And if you go even one step further to 3 sigma interval, then 99.7% of all the data will be contained or will occur within that interval. Okay. So this tells us that if you construct a 3 standard deviation interval, then almost all the data values must fall inside that interval. So if you find a value that's outside that, so that means there is a good possibility that there is something wrong with that particular. That's a very unusual observation. Almost all the observations are supposed to fall within this interval. This concept can be used in quality control, as we will discuss in the next course, Production Operations Management course. We will use this concept to develop quality control intervals. So this is the case for empirical rule when you have a nice symmetric distribution. But suppose if you don't know what the underlying distribution is, then what do we do? Yeah. Now for that we have what is called Chebyshev rule. Chebyshev rule works slightly differently. So instead of saying 1 standard deviation, 2 standard deviation, 3 standard deviation, it lets you figure out whatever number of standard deviations you want or the interval you want. So k standard deviations, whatever it may be. From the mean, you go k standard deviation on either direction. Okay. There is only one caveat, and that is this k has to be greater than 1. It cannot be 1, it cannot be less than 1, and then the rule breaks down, it won't work. So as long as k is greater than 1, then if you construct a k standard deviation interval, then 1 minus 1 over k squared, and if you express that as a percentage, that's the proportion of data that will fall in that interval. Okay. So two differences in empirical rule. Okay, you have to have bell-shaped distribution. Chebyshev rule applies for anything. Empirical rule, you go only 1, 2, and 3 standard deviations. Chebyshev lets you construct any number of standard deviations as long as it is greater than 1. So here is computation. If k is 2, then you plug in 2 here and you get 75%. So at least 75% of the observations will fall within 2 standard deviations, as opposed to in the case of empirical rule, it is 95%. Here in Chebyshev, you can only say that 75%, because Chebyshev rule applies to any distribution, irrespective of whether it is bell-shaped or not. So the numbers you get are more conservative than in the case of empirical rule. In case of 3 standard deviations, you plug in 3 and you get 89%, close to 89%, as opposed to 99.7% for empirical rule. So let's apply these concepts in Excel. So example 3.14 is about a population of 2-liter cola bottles. Okay, and the machine is set to fill at an average fill weight of 2.06 liters and a standard deviation of 0.02. Okay, the label says 2-liter bottle, and the machine is set to fill 2.06 liters with a standard deviation of 0.02. So with that information, Now we'll use the empirical rule and we'll use the Chebyshev rule and then see what the interval of the fill weight will be for the bottles. Okay, let's first define what X is. So we have X is fill weight amount of cola in a 2-liter bottle, and we are given the value of mu and sigma. So mu is 2.06 liters, sigma is 0.02 liters. Okay, now when we use empirical rule is 1, 2 or 3 standard deviations. Okay, then we'll do K times sigma and we'll absolute reference that. Okay, then the lower limit will be mu, absolute reference that, minus K sigma, and then mu, absolute reference that, plus K sigma. So this is the interval for 1 sigma, and then for 2 and for 3 sigmas. Okay. Now in each of those intervals, what is the proportion of bottles will be present in those intervals? Okay. For 1 sigma interval, about 68%. For 2 sigma interval, about 95%. And for 3 sigma, 99.7%. Okay. So that's our empirical rule. Now Chebyshev's rule, okay, and you can have K, as long as K is greater than 1, it can be any number. So let's try 2 different numbers, 2.5 and 3. Now remember, empirical rule assumes that the data has bell-shaped distribution, and here it is not. So K times sigma, you have to absolute reference that. Okay, and then the lower and the upper limit will follow the same formula like here, so we can copy that. So these are the intervals, but what proportion will be present in that interval? That's given by 1 minus 1 over K squared. Okay. That proportion, 84%. So we'll express that as a percentage. Okay. And 88.9%. So if it has bell-shaped distribution, we know almost certain that all the bottles will have at least 2 liters because the lower limit is 2. But if it is not bell-shaped distribution, you can be sure of only 88.9% of the bottles to have the labeled amount of cola. So for about 11% of the bottles, it's going to have less than, lower limit is only, so it will be less than the lower limit. Okay. So that's a problem. If you want to set a very high standard, this is not setting a high standard. If it is high standard, you want really 99%. Suppose we want to see, okay, we take the Chebyshev's theorem and turn it around backwards. So instead of starting out with K, let's start out with the percentage and then see what interval will contain that percentage of data. In this case, that percentage of bottles. So here is the derivation of, you start with the percentage P, okay, and you express that as a proportion. Then you do some algebraic manipulation and you get K equal to square root of 1 over 1 minus P. So this will be square root of, okay, 1 over 1 minus P, 2 right parentheses. So K equal to 10. So you need K equal to 10 interval for 99% confidence, if you will. So if you want to look at what would be the minimum amount of cola in the bottle for 99% of the bottles, then it is 1.86. The upper limit being 2.26, which means a 2-liter bottle, so you have to make it big enough to hold 2.26, because that's the machine is set. If it does not have a bell-shaped distribution, it's set to fill anywhere between 1.86 to 2.26 liters of cola. So this kind of information is very useful in manufacturing situations. Of course, here the percentage of data would be 99%, like from there.